Hello, everybody. So welcome to the Wireshark show that I started about a year and a half ago, I guess, right? So to quote Maverick in a recent movie of his, it's been a minute, huh? So I apologize for the long delay, but as you know, a lot of things happen in the world, and here we are, got going again. And I wanted to remember this was, if you go back to my playlist, I'll try to put it in the description or one of the cards up here. It was meant to be from the very beginning theoretical, but from a practical perspective, right? So it's not just theory, pure theory of TCP/IP. It was as a troubleshooter, how do you use that knowledge and theory as you're troubleshooting? That's what we're going to do today. And again, we're going to start from the very basics. The irony here is that I recorded this yesterday. And I said in that recording, hey, I had 3 more recordings ready to go. Didn't really upload it because I wasn't really motivated to do that. And then as I was editing the sound, I was like, I didn't like the sound, and I deleted them all. So that was the recording yesterday. The irony here, of course, was that because it's been a minute, I forgot all the settings, and my limiter was on my digital audio recorder, and so it chopped off the sound. And so I had to deal with that, troubleshoot that. Then it turned out one of my cables was bad, so there was a lot kind of a buzzing noise that shouldn't have been there. So I tried to clean it up with Isotope RX9, finally gave up, and here we are shooting it again. But this is going to be one take, so here we go. So today's topic, TCP SYN SYNAC. What does it mean? And sequence number. So before you tune away, if you're used to it and you're like, I know sequence number, I'm good. That's fine. You're dismissed if you're confident about that. But from a troubleshooter perspective, as you troubleshoot more difficult problems, these are things that you should know and file away. I'll give you an example. Can you answer what sequence number really means? Just a short answer. What is it? It's nothing but amount of data sent to the other side. That's all it is. Sequence number is data, number of data, bytes of data, chunks of data, buckets of data that got sent to the other side. That's it. Okay. Now, sequence number, initial sequence number when you have the SYN packet is nothing more than a random number. There's 8 bytes, so 2 to the 32. You have, 4 billion or so to choose from, and you pick a sequence number, and that's your start. That's all it is, and then you start adding how many bytes you transfer to the other side. And then you have the acknowledgement number that comes back saying, hey, I've acknowledged up to this many bytes. Go ahead and start here. But think about it this perspective. When we talk about TCP, it's connection-oriented. Sockets get created. That's the SYN, SYNAC, and ACK. That's connection-oriented. There's flow control. That's TCP window that's throttling up and down. And then it says streams protocol. It says it streams. What does that mean? Again, there is no beginning and end to TCP. Okay, it's just data. The print job could be gigabytes, terabytes. There is no beginning and end like there are in other file systems. So typically in other file systems files, you have a beginning marker and an end of file marker. So even executables, every executable in Windows world starts with the letter MZ. I believe that was the initial of the guy that made the compiler for Microsoft, and he said, you know what, as a start blocker, I'm going to use my initial MZ. So if you open up any executable, Windows executable, you'll see it starts with the letter MZ. That's the kind of the beginning of file marker. TCP doesn't exist. It's just constant stream of data. So remember that as you're troubleshooting. The other thing, acknowledgement number I said was, hey, this is how much data I sent to the other side, right? I just said that. So when you're looking at TCP SYN packet, let's go to and click that up, and let's move myself to the lower right corner. All right. So here we are with the TCP SYN. Let's open it up to the transmit TCP side of the house. And first thing you'll notice that there's a SYN. We're not going to worry about the explicit condition notification here. We're just going to concentrate that this is the SYN, this is the SYN and the ACK, and then the ACK, the 3-way handshake that I'm sure all of you are familiar with. But here's the thing. Here's the sequence number. This is the raw sequence number. This is what's called ISN, initial sequence number. Again, random starting point. So what Wireshark said was, hey, as humans, it's kind of hard for us to deal with all these numbers here, right? And a lot of troubleshooters before this relative sequence number was available, we almost always tried to memorize the last 4 digits and just kind of know to increment by 1 on the 10,000th marker here. Okay, so because again, it's hard to recognize this number when you're trying to do this very, very quickly. So then Wireshark developers said, hey, since this is just a start, it's just a random starting point, why not give it a relative sequence number of 0? That's the kind of the ground floor, ground 0. And by the way, if you've ever been to Europe, a lot of elevators will be marked as 0, ground floor, and first floor is in fact 1 level up. That's engineering-wise, that's correct, but of course here in the U.S. we have first floor is the bottom floor. Anyway, just the odd things that I notice when I travel. All right, the other thing is that I just said that acknowledgement number is how much data I've acknowledged, so I can tell the other person I've acknowledged up to this much, right? So here's a question. This is a TCP SYN packet. You can see here, length is 0. So SYN, length is 0. So my sequence number here is 543. I didn't send any data, but yet when the other guy comes back with the acknowledgement number, he says 8544. You can see here 8544. Initial SYN number is 8543, and the acknowledgement number says, yep, go ahead and start with 8544. Even though there was no data, TCP SYN, we have a fake data. Okay, so let me show you what I mean by that. And when you're doing sequence number analysis, TCP sequence number analysis, I said it was fundamental. Don't do it 2 ways. Okay, TCP is like talking on a phone. Both sides can talk at the same time. Yes, there's interference, but you can talk. Both sides can talk. When you're first starting out, only start from one sender sequence number and the acknowledgement number from the receiver. Ignore the other sequence number because it's a duplex communication. All right, because otherwise you'll get kind of confused and wrapped around the axle. So that's just one advice that I have for you. So let's talk about the first SYN. Okay, so this is the SYN. What is it? A knock on the door saying, hey, I want to talk to you. So here's a server. And this is the PC. And then, of course, the server says, sure, I'm going to talk to you. And I'm going to do 2 things. I'm going to acknowledge your knock on the door. And here's my knock on the door. And then finally the PC says, yep, I acknowledge your knock just like you acknowledged my knock. Right? So this is the 3-way handshake. You knock on the door. He acknowledges that knock. He sends his own knock. And then the PC acknowledges that the other return knock coming. By the way, this is fundamentally what's wrong with TCP in a modern world of zero trust. Why do I say that? Whoever's knocking, you have no option but to answer. Think about that. This could be some bad guy, right? Could be a good person. Who knows? Could be an authorized user or an unauthorized user. You have no idea who that is that just knocked on your door, but because the way the protocol was written back in the days, you have to answer with the SYN of your return knock and open that door. So think about that. Somebody knocks on your door at 2 o'clock in the morning. You have no choice but to open the door. Who would do that, right? Of course not. Nobody does that, but that's how TCP works. And this is why, if you heard the term zero trust come into play, zero trust models say, let's not do that. Let's not have every TCP SYN be answered, etc. Okay. So if you're interested in that, leave me a comment down below and I'll get into it. But that's a different topic altogether. And by the way, that's every YouTuber does this. That's just a sly, we think it's sly little way of trying to encourage you to leave a comment so that YouTube algorithm will say, oh, this guy's interesting. A lot of people are typing on his comment section. Let's advertise this to other people. Okay, so you'll hear a lot of YouTubers say things like that. Oh, what do you think about, this is the best movie. Princess Bride, in fact, is the best movie. Tropic Thunder is probably number 1, number 2 as well. So those are my 2 favorite movies. And we think that's a sly way of getting people to comment, but I know you're smarter than that, so I won't cater to that. All right. But do like and subscribe and leave a comment so that other people can see this video. Let's get back to the sequence number. So we said, here's the PC, here's the server, and the PC asked for a file. Okay. So now how do those packets come across? Let's say this is a bad telnet session or SSH session. Okay. So the PC is going to transmit, and the server is going to receive these bits of data for simplicity's sake. So what happens? Each packet leaves, because it's a slow telnet session, I type and wait 30 seconds, type again, wait 30 seconds. Each one of these packets have 1 byte in them. That's it. Okay? So this is packet number 1 here, packet number 2, packet number 3, etc. Those are the packet numbers. All have 1 byte of data. So the sequence number and acknowledgement number, how does that work? All right, so first, let's assume that the server, this PC, sent these 2 as a packet train. Okay, so those 2 packets left. So this is packet number, obviously packet number 1, packet number 2. So what is the acknowledgement number? Because remember, this is 1 byte here, another byte here, right? So this is 1 byte, this is another byte. What's the acknowledgement number going to be? Is it 2 or is it 3? Which one do you think it is? So again, when you're first starting out, you have to get this concept down so clearly that you don't have to think about it. It's like breathing. We don't think about breathing because of course you're going to breathe. That's how well you need to know this and what it means and what it implies as you get into the more advanced sessions. So think of it this way. The best analogy I can give you is that you are a the train conductor, okay, and there's 2. One at the gate, counting how many passengers are going by, okay. And so when you have a conductor counting, you've all seen those metal clickers, right? That click, and you count how many passengers you let on. Let's say there's another conductor on the train, that's clicking as the passengers are actually boarding that train. So the sender clicks off, hey, I sent 2 passengers. Okay, passenger 1, passenger 2, and where's passenger 3? Okay, this is kind of the imagery that I want you to get into your mind. I sent passenger 1, passenger 2, byte 1, byte 2. Where is byte number 3 or passenger number 3? Standing right next to me, because I haven't let him go yet. Okay, the conductor, his acknowledgement that comes back is, okay, go ahead and start with passenger 3. So he doesn't say, I received 2 passengers explicitly. He says, go ahead and start with passenger 3, which implies that he has passenger 1 and passenger 2. So he says, I get the acknowledgement saying, okay, so we know the answer is go ahead and start with passenger 3. So this packet reaches here, right? Oops, sorry, let me go back to here. So this is passenger 3. So, I'm sorry, so my orientation was wrong. So passenger 1, passenger 2, byte 1 and byte 2 gets. The acknowledgement number says go ahead and start with passenger 3. So once this packet arrives here, we know 1 and 2 are good to go. It's been accounted for. Okay, so then we go ahead and send passenger 3 and passenger 4. Okay, each with 1 byte. Make sense? All right. So once so where's passenger number 5? Okay, let's go back to my analogy here. So now I have passenger 3 and 4, click, click. I sent them off. So there's 4 that went across. Passenger 5 is next. Where's passenger number 5? Sitting right next to me. What is the acknowledgement number coming back from the other side? he says, go ahead and start with passenger number 5. Okay, start with passenger number 5. I look at that message, I see passenger number 5, we're in agreement, and we send the packet off. Okay, that's the easiest way to think about what sequence number and acknowledgement number means. So let's go to a trace file, and some of you must be rolling your eyes like, finally, Wireshark interface here. So again, let's put it all together now, and I'll go fairly quickly because you can always rewind and listen to it again. But so there's no data, but there is no data, but I do need to force the other side to respond back to me. So in the RFC, we says, okay, for the SYN packet, we're going to pretend there's 1 byte of data so we can get that feedback. All right. So even though there's no data, my sequence number, I'm going to use a real sequence number here in this use case. So this ends with 543. I send 1 passenger, and he says, okay, go ahead and start with passenger 544. Okay. So in other words, I incremented 1 saying, go ahead, I've acknowledged the 543 passenger, go ahead and start with passenger 544. So let's go back. So this, that other conversation that's happening, we're going to ignore. So the source is 101. Let's go to source 101 and the sequence number. Okay. Oops, sorry. So my sequence number 104. Sorry, we're going to 104, and you can see my sequence number is 544. Again, no length, just an ACK. That's okay. So I'm going to start with 544. And sure enough, I start with 544, and I sent 134 passengers. This time, I clicked off 134 passengers. And when you do that math very, very quickly, you know that, and Wireshark actually counts this for you, and it says next sequence number is, well, this is relative sequence number, but all you do is add 544 to 134. Okay, do that math, and the acknowledgement coming back from the other side is 8678. Okay, so 8678 is the right number because that's saying go ahead and start with passenger number 678. So let's go back to the next packet here that 104 is transmitting, and sure enough, we're going to start with passenger number 8678. Okay, now 2 sides have agreed. In the previous acknowledgement packet, he said, you know what, when you start next, this is the ACK number now, go ahead and start with passenger number 8678, meaning he has all the passengers up to 8677. Okay, this is start with passenger number 8678, and then sure enough, when I start 104 is transmitting again, I start with passenger number 8678. This is how we keep things in order. This is just an acknowledgement, so he doesn't have any data. The very next packet, we're going to have the same sequence number. Looks like this is just acknowledgement again. And then here we start with 8678, and we have 182 more passengers going to the other side. Okay, so to sum up, sequence number is nothing more than a starting point. It's just a number. Then you start adding how many data you sent to the other side, and the way the other side acknowledges you is by saying, go ahead and start with the next passenger or the next byte. That's how TCP guarantees delivery. There's a little bit more to that story, and maybe we'll get into that in the next video, which should come out next week. But I also discussed that, and I'll put the cards here or description here in my playlist where I talked about the send buffer, receive buffer in a previous video. And oh, by the way, if you're wondering why I have this kind of a towel out here and this GoPro sitting on this board here, is because the very next video I'm going to remake, because that sound problem that I had, is how to actually terminate cables. So we're going to go down to the physical layer of troubleshooting by showing people how to create and terminate jacks. All right, with that, thank you very much, and we'll see you next time.